Hey guys, so today we're going to be talking about compound events, and then so after this is going to be day 1, then there'll be day 2, then we'll take our second PC for this unit, and after that, this unit's actually done. This is the last new piece of information, so that means that after this, you guys will have the PC that does this compound events and conditional probabilities, and then you're going to have the final PC that covers all of the probability stuff that we've been doing. All right, so first off, a simple event is just a single outcome. So an event that describes a single or one outcome. So only one thing's going on. A compound event is when more than one thing is going on. So an event made up of 2 plus simple events. I feel like I should draw an arrow up instead of a plus sign because it looks like a T. Okay, these next couple of rules are stuff that we've already gone over. So when things are mutually exclusive and they're or, so for 2 mutually exclusive events, A and B, when it's or, remember this means or, so when A or B is happening, you just have to add. If they're mutually exclusive, they have no overlap. So like the probability of rolling a 1 or a 2 would be the probability of 1 plus the probability of rolling a 2. So 1/6 plus 1/6 is 1/3 or 2/6. Okay, inclusive events, remember this still means or. So if they have overlap, so this would be the equivalent of having this. So this is A, this is B, they have overlap. You have to subtract the overlap. This is if they have no overlap. Here's A, here's B. Okay, if they have overlap, you have to subtract the overlap. This is the overlap. This means and. Okay, so like the probability of rolling an even number or a prime number. Well, because 2 is an even prime number, you have to count that. There's an overlap of 1/6. So you do 3/6 plus 3/6 minus 1/6, and you get 5/6. So there's actually only one number that you can roll that is not prime or even. It's 4. You can't roll a 4, and that would not fit those categories. Okay, so mutually exclusive events. So we're going to decide, are they mutually exclusive? Yes or no. That's it. That's all we're deciding. We're not going to be finding those probabilities. We're just deciding, are those events mutually exclusive? All right, so on this first one, rolling a 3 or rolling a 4. Can you roll a 3 and a 4 at the same time on a single dice? No. So these are mutually exclusive. Yes, because you can't roll a 3 and 4 at the same time. Okay, let's look at this next one. Rolling an even number or rolling a multiple of 3. Okay, so are these mutually exclusive? So first off, what are the multiples of 3? 3, 6, 9. How many of those are on a dice? 3 and 6. Is 3 an even number? No. Is 6 an even number? Yes. So because of that, you can do these both at the same time. So these are not mutually exclusive. So the set of 2, 4, and 6 are even numbers. And the set 3, 6, which are the multiples of 3, have one number in common. It's the number 6. Okay, rolling a prime number or rolling a multiple of 4. Okay, so let's look at that. So we'll leave a space for our yes or no. So prime numbers would be 2, 3, and 5. and then multiples of 4, so these are my prime numbers, and then the multiples of 4 on a dice would just be 4. So do these have no overlap, or do they have overlap? No overlap, so they are mutually exclusive. So I'd put yes. So no overlap. Okay, so in a deck of 52 cards, drawing a red king or a black king, is there any overlap there? No. So yes, these are mutually exclusive because a king cannot be red and black in the card game. Okay, each student can vote for president of student government. 32% vote for Sparks, 28% vote for Kolb, and 40% vote for Ramos. Voted for Ramos. Okay. Is there any overlap if each student can vote for president? I'm hoping the answer is no. There's no overlap. So these can be mutually exclusive. Yes. They can only vote once. And if they can only vote once, they can only vote for one president. Does that make sense? Okay, we're going to find the probability of mutually exclusive events, and then we're going to find the probability of not mutually exclusive events. We've done some of this a little bit before, so it's just going to be good practice for us. So a group of students is donating blood during a blood drive. A student has 13 out of 30 probability of type O blood, a 6 out of 15 probability of having type A blood, and a 2 out of 15 probability of having type B blood. Okay, so what's the probability a student has type O or type A? So can these overlap? No, you can't have type O and type A. You have to have one blood type. So that means we're going to take the probability of type O. So that's 13 out of 30. So this is going to be the probability of O plus the probability of A. So 13 out of 30 plus, and then type A is 6 out of 15. Which, if I make these have a common denominator, this is really actually 12 out of 30. So then if I add these two together, I get 25 out of 30 chance that a student will have type O or type A. Okay, so what's the probability that a student has type A or type B blood? And again, type A and type B cannot overlap because you cannot have type A and type B in this scenario. So then you're going to have 6/15 for type A because this is the probability of A. And then we're going to add the probability of B. And the probability of B is 2/15. So we have 8/15. Does that make sense so far? All right, in this next one, it says, in a deck of 52 cards, what's the probability that you choose a king or a queen? So first, we have to know how many kings or queens are there. So there's 4 suits, and each suit has 1. So how many kings are there? So there are 4 kings, and there are 4 queens. So we need to do the probability of kings plus the probability of queens. So that'll be 4 out of 52, which is 1/13, plus 1/13. So 2/13 is the probability of king or queen. Okay. Any questions there? All right, let's move on to the probability of inclusive events. So if a card is drawn randomly from a 52 card deck of cards, what's the probability of each? So drawing a queen or drawing a heart. Now, we have to think about this. So hearts, there are 13 hearts out of the total 52. In queens, there are 4 queens out of the total 52. But how many of those queens, so this is the probability of queens, this is the probability of hearts, but how many queens are also hearts? There's 1. So we're going to have to subtract the probability of queens given hearts. Or queens and hearts. So that's going to be 1 out of 52 because there's 1 card out of the total 52. So we do 4 plus 13 minus 1. So we get 16 out of 52. Which is the same thing as 4/13. You can check that with the calculator if you want. I'm not going to do it right now. Okay. And I should really rewrite this. So it says queens intersect hearts. Okay. So on this next one, it says, what's the probability of drawing a black card? So there are 26 out of the 52 cards are black. So this is the probability of black. Okay. Or a face card. So plus. Now there are 3 face cards for every suit. So that'd be 3 times 4. So that's 12 out of 52. So this is the probability of face cards. And then we need to subtract the probability of the black cards that are also face cards. So that would be 6 because there would be 3 spades and 3 clubs that were Jack, Queen, and King. So that'd be 6 out of 52. So we do 26 plus 12 minus 6. 26 plus 12 minus 6. So we have 32 out of 52. Yes. Sorry, I was checking my math. I was very concerned about myself. Which is the same as 8 13ths. How you feeling? Hopefully you're okay. Okay. So we're going to find the probability of each of these. What's the probability of rolling an odd number or a number greater than 2? So let's look at odd numbers. So odd numbers on a dice are going to be 1, 3, and 5. Now let's look at the numbers greater than 2. So this is going to be 3, 4, 5, 6. So the probability of rolling an odd number is 3 out of 6. Plus the probability of rolling a number greater than 2 is 4 out of 6. And then how many of those numbers overlap? So there's a 3 here and a 3 here, and a 5 and a 5. So we're going to subtract 2 6. So 3 plus 4 minus 2. So this is 5 6. Does that make sense? All right. So what's the probability of rolling at least 1 5 when rolling 2 dice? Interesting. So you got to think about this. So when rolling 2 dice, you're rolling your probability of rolling a 5. So you're really thinking about the probability of rolling a 5 or a 5, 1 on each dice. And then you need to remember to subtract the probability. So this is going to be the same thing. So you could roll a 5, or you could roll a 5 on each dice, and it's going to count that one twice. So this is going to be the probability of 5 plus the probability of 5 minus the probability of rolling 5 on both dice. Which you would only count the double 5 roll once, right? So the probability of rolling 5 on the first dice, there's going to be a 1/6 chance on that. The probability of rolling 5 on the second dice, there's a 1/6 chance out of that. Now, if you remember, if we roll 2 dice, there are a total of 6 options for the first dice times the 6 options for the second dice. So first die, second die. So there's a total of 36 options for dice. So what's the probability of rolling double 5s? There's 1 out of those 36 chance, right? So minus 1/36. This is going to equal 11/36. And you can do that in a calculator. You could do 1/6 plus 1/6 minus 1/36. You hit enter, you get a really gross decimal. And you push math and enter twice. 11/36. Okay, how you feeling? That's as far as we need to go today. Hopefully you're feeling okay. Love you guys.